Thanks so much for having me here. This is exciting to be here. So I'm going to be talking about the new era of NLP today. In the past year and a half, there's been a lot of huge advances in the field of natural language processing, and the field is really still kind of in a state of flux, where kind of best practices are still kind of being, reestablished as they're changing, and I think that makes it a really exciting time to get involved with NLP or learn more about the field. This was featured in the New York Times in November. There was an article, Finally a Machine That Can Finish Your Sentence, on some of these improvements. Sebastian Reuter, who's an NLP researcher, wrote a great article, NLP's ImageNet Moment Has Arrived. And if you're familiar with computer vision, ImageNet is this competition that really spurred on a lot of progress in the field. And so this is kind of, we've reached that moment with NLP now. And then earlier this year, The Verge covered OpenAI's release of GPT-2, and both kind of the good things about it as well as the risk. And this is something that got a lot of media attention that I'll talk about more. I want to highlight that at FastAI we released an Nlp course earlier this week. This is completely free, all available online. If you're interested, you can check it out. And it's kind of taught through Jupyter Notebooks, available on GitHub, and lecture videos on YouTube. And it covers a blend of kind of older, or I should say more classical techniques in NLP, as well as some of the recent advances. So what is NLP? This refers to natural language processing, and it's a really broad field. So this is a GitHub repo maintained by Sebastian Reuter of a bunch of different NLP tasks and what the state of the art is. And you can see there's kind of a huge variety of tasks here. Summarization, question answering, language modeling, which I'll talk about more later, part of speech tagging, automatic speech recognition, so also kind of voice-to-speech is in the field of NLP. So it's a very broad and useful field. Two particularly maybe common uses that you might have seen. One is in Gmail Smart Reply. It'll automatically recommend a possible suggestion of how to respond to an email. It's also doing a kind of auto-complete for your subject and as you're typing the email now. So here someone's emailed, I expect the work to start tomorrow, sorry for all the delays, and Gmail has come up with 3 possible responses that you could send. Another kind of commercial application of NLP is translation, and so Skype and I believe many other services are now offering real-time translation where you can be speaking to someone who speaks a different language and getting real-time translation between them. So what software should you use for NLP? So I definitely recommend Python as an excellent language for NLP and very commonly used. At FastAI we love Jupyter Notebooks, and so I think they're a great tool for education and research, but we've also moved all our software development into Jupyter Notebooks, including testing. So we kind of use Jupyter Notebooks for everything now. I want to give a shout out to SciPy as a great NLP library, industrial strength natural language processing. And SciPy is a kind of very opinionated library in a good way, of where it gives you kind of one way that's very state of the art and optimized to do things. For deep learning, which I'll talk about more in a moment, I love PyTorch. At FastAI, we switched into PyTorch, I guess 2 years ago. And PyTorch is a neural network framework from Facebook AI group. And it's an alternative to TensorFlow, which is Google's AI framework. And we found PyTorch to be both faster and easier to debug than TensorFlow in our experience. And then at FastAI, we have a software library built on top of PyTorch, and this is kind of a high-level API. It's intended to be beginner-friendly, but also to include a lot of state-of-the-art techniques and be something that kind of advanced researchers can use as well. And these are all in Python. So today I want to say just a little bit of background around deep learning, since this is kind of what's responsible for this, kind of all these huge advances in NLP that have happened in the last year or two. And in particular, I want to speak about transfer learning, which is one particularly powerful NLP technique. And then I'm going to talk later about some of the risks that are posed by advanced NLP, particularly disinformation. So just briefly, as a little bit of background, deep learning refers to multi-layered neural networks. Deep learning is this family of algorithms. It's a subset of machine learning, which is a subset of AI. And AI is a kind of very broad and general term. But typically when I refer to AI, or a lot of the kind of concrete advances that you hear about happening in AI right now are all coming from the field of deep learning. So 4 very common myths about deep learning are, one is that you need big data. This is not the case. Or that you need lots of expensive computing power, also not the case. That you need a deep learning PhD from Stanford. I should note the FastAI course, the only prerequisite is 1 year of coding experience, and it takes people to the state of the art in deep learning. This is practical deep learning for coders. Or that deep learning only works for very limited problems. Again, it's being kind of applied to a pretty wide variety of problems. So one of the things that's allowed neural networks to be so effective now in a way that they weren't a few decades ago is GPUs, graphics processing units. This is the card inside of video games or computer games, and it's the exact same computation, or it optimizes the same computation that you need for neural networks. And so we're kind of indebted to the gaming industry. Most practical real-world projects we know of or work on only require a single GPU. And you can run a GPU for 45 cents per hour in the cloud. So this is a lot more affordable than many people realize, because you'll often hear about research kind of coming out of Google or OpenAI that's millions of dollars worth of GPUs. But for many use cases, that's not what you need at all. And so part of the reason that small data and few GPUs can be so effective is because of a technique called transfer learning. And so transfer learning is where you take a network, or kind of take a large data set and train a network on it, and then share that and apply it to a smaller data set. So for instance, ImageNet, this incredibly well-studied large data set that was a subject of a series of competitions, many of the winners have open sourced and released their networks, and people can fine-tune those to smaller, different data sets. ImageNet contains a lot of pictures of kitchen appliances and different types of plants and animals and vehicles. And say you're working on chest x-rays, this is a different type of image. It's not a category in ImageNet, yet it's still really effective to fine-tune your network to this kind of smaller and different data set that you're using. Neural networks kind of learn information that transfers to new problems. So the reason transfer learning is effective is that kind of the early layers of the network in particular are learning features that generalize. And so for computer vision, this can include corners or circles. And then the later layers tend to have more specific features. Transfer learning is not just for computer vision. I'll talk about how it applies to NLP in a little bit, but this graph is from an NLP paper, ULM-FIT, and basically the blue line, so x-axis is number of training examples, y-axis is the error rate on a validation set, and the blue line is training from scratch. The green and orange lines are with transfer learning, and you can see that they get a much lower error rate much faster. So just a few examples from FastAI students. One is Nikhil Balaji, and he downloaded just 30 pictures of people playing cricket or baseball, and that was enough to train a classifier to tell the difference. And here he's using transfer learning on a model that was originally trained on ImageNet. And so this is a much smaller data set than most people would expect you can use. You can also achieve state-of-the-art results with transfer learning. So another student, Savash Sapalia, this was after the first week of class, downloaded the Devangari character set. And so these are images of handwritten Devangari characters, and the task is to classify which character it is. And he improved the state-of-the-art from 98.5% to 99% using transfer learning. Ethan Sutton downloaded a set of environmental sounds. These include things like children playing, drilling, street music, and engine idling, and again, achieved state-of-the-art results, beating kind of published work in this area using transfer learning with just 1 week of background. And then one final example is Elena Harley. She's a researcher at Human Longevity Institute working with a lot of genomics and bioinformatics data. And she's looking at the problem of cancer metastasis. So when cancer is moved elsewhere in the body, identifying the site of origin can be an important question for treatment. And she reduced the previous error for state-of-the-art by more than 30%, while at the same time discriminating over many more classes. So she made it a harder task and got better results. And she's written a great series of blog posts on her work that you should check out. So that's a little bit of background about kind of what transfer learning is. And now I'm going to talk about how it's applied to NLP specifically. So in 2013, Google released Word2Vec, and I just want to check who here has heard of or used Word2Vec or similar. Okay, so I see a lot of hands going up. So these are word embeddings, and the idea is that these are kind of high-dimensional vectors that have captured a lot of semantic meaning about language to represent words. And so here's kind of an example that kitten and puppy might have similar vectors because they have a lot in common semantically, whereas avalanche is this very different word, won't be as similar. The word embeddings can capture relationships, so man is to king as woman is to queen. And Word2Vec is just one library that's available. There's also Glove from Stanford, Fast Text from Facebook, and I'm sure many others. And these are kind of a very popular and widely used tool as a way of representing words as a high-dimensional vector. Word embeddings are useful because they have captured all this meaning. That includes things like verb tense, so the relationship to from walking to walked is similar to swimming to swam. You can also see relationships between countries and their capitals. If you want to learn more about word embeddings, I gave a workshop on it that's available on YouTube, Word Embeddings, Bias in Machine Learning, Why You Don't Like Math and Why AI Needs You. And that includes kind of a demo in a Jupyter notebook, all in Python. And so, as I said, word embeddings kind of were first introduced in 2013, 6 years ago. They're very useful. But word embeddings are like using one pre-trained layer for your network. So this is something that researchers at Google or Stanford or Facebook have trained on this huge corpus of historical text. And so that's useful, but it's just kind of one layer from the network. What if you could use many pre-trained layers? And so this is kind of the big transition that's happened just in the last year, is to transfer much more of the network and not just a single layer. And the first successful application of this was ULMFit, which stands for Universal Language Modeling, fine-tuning for text classification. And this is work by my co-founder, Jeremy Howard, and Sebastian Reuter. This technique's been built upon with more recent advances of BERT, GPT and GPT-2 from OpenAI, XLNet from Google AI. I should say BERT's also from Google AI. So kind of a lot of research is coming out using transfer learning now for NLP. And so I'm going to explain a little bit of how this works through the example of ULMFit. And first I just need to introduce what a language model is. And so a language model is a model that predicts the next word in a sentence or piece of text. And basically you can then predict the next word after that and the next word after that and use it as a way to generate text. So here's a language model that I trained, and I seeded it with the words, I hated this movie. So I gave it those words, and then the model predicted what came next after that. And so this is what it came up with. I hated this movie, but the film was a hit. It was the first film to be shot in Italy. It was released on DVD, and I hated this movie, but the film was a commercial success. The film was released on DVD and Blu-ray in November 2010. And so you can see there are a few errors in there. It's not perfect. This is also, I should say, I didn't train this for that long. So this is trained on a slightly different data set. Another model, I gave it, I liked this movie as the prompt, and it came up with, I liked this movie because it is one of the best movies I've ever seen. It is full of great laughs and great acting. It is the first movie I have seen that was so good. And so I'll highlight that the difference between these two models is the first one was trained on text from Wikipedia, which I think kind of comes through, like you can see in the language that it does sound a little bit more like a Wikipedia entry, and the second one was trained on IMDb movie reviews, and I think it does sound more like an IMDb movie review. So that's something kind of how the text you train on, influences, of course, what your model will predict. And so this is actually kind of part of the core idea of ULM-FIT is to train a language model on Wikipedia text, and then to fine-tune that for your particular task, which in this case was IMDb movie reviews. And so that can involve, so you've got your language models and you're predicting what word comes next. Here with these sentences, you could guess, I'd like to eat a hot dog versus it was a hot day, might be the kind of the next words in those sequences. And then you add a classifier onto the end of that. So now we're going to try to tell, is the movie review positive or negative? And having this background knowledge about how language works that the models learned through the language model is useful in coming up with the sentiment classification, so that improves the accuracy. And so there's kind of two transfers going on here. There's going from your data from Wikipedia to the IMDb movie reviews, and then going from this task of predicting the next word to a classification task, here telling whether the movie review is positive or negative. So in ULM-FIT, they looked at six different classification tasks, and for all of them, they had started with this model that was trained on Wikipedia, or Wikitext 103, which is a large data set, a subset of Wikipedia. They looked at some sentiment tasks, so predicting if a Yelp review was positive or negative, also predicting if a Yelp review had 1 through 5 stars. They looked at some topic classification, so given some entries in DBpedia, determining what topic they were. And all of these, they achieved a new state of the art using this approach. And here you can kind of see this graph of results again, where the blue is training a model from scratch, and the orange and green are using this approach. And green is kind of using the best version of this approach, and it just got to a much lower error rate on the validation set, much faster. An example from one of our students is a law student in Singapore, and so they adapted this model to classify Singapore legal judgments as to which category they're in. They had 18 or 19 categories, such as civil procedure, criminal law, contract law, family law, tort, arbitration, and so on, and were able to kind of accurately place which category legal judgment referred to. Yeah, and as I said earlier, there's kind of this approach of transfer learning for NLP is being applied a lot now in cutting-edge research. So in particular, I wanted to talk about GPT-2. And who heard about GPT-2 when it came out in February? All right, I see some hands. This got a lot of attention. And so this was a model from OpenAI trained on a very large data set. And so I'll give one example that they shared. So here the prompt that was human written, that was given to the model, was, in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. So that's what the humans wrote, and then this is what the model generated. Dr. Jorge Perez, an evolutionary biologist from the University of La Paz, and several companions were exploring the Andes Mountains when they found a small valley with no other animals or humans. Perez noticed that the valley had what appeared to be a natural fountain surrounded by 2 peaks of rock and silver snow. Perez and the others then ventured further into the valley. By the time we reached the top of one peak, the water looked blue with some crystals on top, said Perez. Perez and his friends were astonished to see the unicorn herd. These creatures could be seen from the air without having to move too much to see them. They were so close they could touch their horns. While examining these bizarre creatures, the scientists discovered that the creatures also spoke some fairly regular English. Perez stated, "We can see, for example, that they have a common language, something like a dialect or dialectic." And so this is really, I think, compelling prose to have been written by a computer. And there is some, not all the results come out this good, but that a computer can generate this is a huge advance. Kind of qualitatively, I would say, in the quality of what the prose is like. So this is exciting, but this also raises a number of risks. And so Jeremy, my co-founder, was quoted in a Verge article about this, saying, "We have the technology to totally fill Twitter, email, and the web up with reasonable sounding, context-appropriate prose, which would drown out all other speech and be impossible to filter." And so this is really concerning, and I'm going to talk a little bit more about this. And I want to note that the OpenAI team was trying to kind of raise an alarm about this risk, and they did not. They did this idea of staged release, where they kind of released a smaller version of the model, leaving open the possibility that they'll release more later. And so to do that, I want to kind of talk about some, I think, potential use cases. So I'm going to jump back to 2017. So again, GPT-2 just came out in 2019. 2017, the FCC was considering repealing net neutrality. And they opened up for comments to hear what did citizens think about whether net neutrality should be repealed. They received 22 million comments. Here are a few of them. Americans, as opposed to Washington, and these comments were all in favor of repealing net neutrality, so they were anti-net neutrality. Americans, as opposed to Washington bureaucrats, deserve to enjoy the services they desire. Individual citizens, as opposed to Washington bureaucrats, should be able to select which services they desire. Citizens, rather than the FCC, deserve to use whichever services we prefer. You might notice a pattern with these, right? They sound a bit almost like a Mad Libs. And so this is something that Jeff Cow, a data scientist who's now a computational journalist at ProPublica, did a really excellent analysis of. And he discovered that less than 4% of the 22 million comments were truly unique, and that there actually seemed to be a number of spam campaigns that had kind of overwhelmingly entered anti-net neutrality comments into the system. And so this, I definitely recommend his blog post on this, was a great analysis. And the comments highlighted on the previous slide were ones he discovered from this group of over a million comments that seemed to be from this kind of Mad Lib style mail merge of plugging in different words in each spot to generate these comments. So this is something that's concerning, can sway kind of the impression of, are people for or against this? And Jeff did a great job on this, but this is something that would be, I think, significantly harder to detect today with more advanced language models. So if you think back to that unicorn story, that could probably come up with much more compelling comments. GPT-2 could. So that's kind of this one risk. And so I think that most people, we all like to think that we're kind of independent-minded and we think for ourselves. But humans, we really evolved to be social creatures and to be influenced, particularly by people we consider to kind of be in our group. And so the opinions of others, and particularly of those we see in our group, really does impact us, and impacts our beliefs. People have a lot of discussions on the internet on a wide range of topics. So this is a discussion from a Reddit thread about the kind of statement it started with. I believe the U.S. should cut all defense spending. There are a bunch of comments in here. Someone saying you're wrong. The defense budget is a good example of how badly the U.S. spends money on the military. Someone else says, yeah, but that's already happening. There's a huge increase in the military budget. The Pentagon budget is already increasing. Another comment, I didn't mean to sound like stop paying for the military. I'm not saying that we cannot pay the bills, but I think it would make sense. Does anyone want to guess what subreddit these comments are from? I've covered it up. That's right, yes. So I heard it, and this was the, it's called the sub-simulator, GPT-2. So all these comments were from GPT-2. And I think this is something where, and many of them, if you read them closely, you can tell they're a bit off. But I think they're close to being compelling. And you could definitely see how it's not a leap to get to a point where they're even more compelling. And this, so I should say this subreddit is kind of all in good fun. It's clearly labeled as, you know, these were produced by a machine learning model. But it's concerning to think about what this technology could do if it was not being labeled. So kind of on a very serious note, there's a lot of radicalization taking place on the internet, and this is, you know, the flip side of something positive of how so many of us have been able to find communities online and find people that we relate to or share values with, but there's also this very, very negative and dangerous side that kind of radicalization, particularly into white supremacy happening online. In November, there was a shooting at a synagogue in Pittsburgh in which 11 people were murdered. And this, the shooter was someone who was, he was very active on extremist-friendly social networking sites, and he even posted directly before the shooting. Earlier this year in New Zealand, there were 2 shootings at mosque, again by a white supremacist. 50 people were murdered, and this is something where the New York Times characterized it as a mass murder of and for the internet. The attack was teased on Twitter, announced on the online message board 8chan, and broadcast live on Facebook. The footage was then replayed endlessly on YouTube, Twitter, and Reddit, and all the mainstream sites were trying to take down the footage, but there were just a lot of copies kept being re-uploaded. And then apparently on sites like 8chan, people or commenters were saying that they were inspired by the attacks, that they were celebrating them. You know, this is terrible. And I'm not suggesting that NLP played a role in this, but I think it's frightening to think about how NLP could potentially be used to even try to scale or magnify what's already a very serious problem further. Because extreme viewpoints can really be normalized when we think that others around us hold those viewpoints, and we're kind of getting to a point where it wouldn't even necessarily have to be actual people, but you know, manipulative campaigns by bad actors could create the impression that many people hold a viewpoint, and that could then, you know, lead to kind of normalizing those viewpoints further. And so just kind of thinking in context, kind of how these could be combined, how this could also be combined with profile photos. So this is Katie Jones, Russia and Eurasia Fellow. She's connected to a number of top Washington think tanks on LinkedIn. It turns out this is not a real person. This is an image generated by a GAN, which is a type of neural network, and neural networks can now make kind of compelling fake images. You can visit thispersondoesnotexist.com to see a lot of examples. And I should note this photo of Katie Jones is not from that website, and this is a story the Associated Press broke a few weeks ago. But you can kind of think of the combination of compelling images of people with commenting in history. And I think often kind of when we think about troll or bot accounts, because they've often been so easy to spot in the past of, that person just has an egg for their profile picture on Twitter, that it can be easy to think like, oh, we don't need to worry about this. They're easy to identify, whereas it's really concerning to think about what will happen as they become more compelling, in the way that online discussion could be swamped with fake or manipulative agents. So as I mentioned before, OpenAI, and there's some things I think they could have done differently, but on the whole, I think they took the risk of language modeling seriously and were trying to raise an alert about that. And they did this through staged release as well as partnership-based sharing. Jeremy wrote a great blog post for the Fast AI blog if you want to read more about this. This was a very kind of controversial decision within the machine learning community. Jeremy wrote a post, though, some thoughts on zero-day threats in AI and OpenAI's GPT-2, if you want kind of more discussion on that. I want to kind of briefly mention other types of fraudulent material, and I think it's kind of helpful to think about fraudulent video and images and text and audio in combination, how compelling those can be. So deep fakes have been in the news a lot. I was on an NPR podcast, 1A, about them a few weeks ago, together with Danielle Citrin and Jack Clark. It was an interesting discussion. Drew Harwell has done some great reporting for the Washington Post. And then actually, I guess this has been getting more attention in the last week, the way that these are primarily being used to harass women right now and create these kind of misogynistic fake sex videos. They're instances of a journalist in India who people have been trying to intimidate and silence her through this sort of harassment. There are girls in high school who have been bullied, threatened with this. So really kind of already a concerning issue. A few things I wanted to highlight are that people often respond to media that confirms their pre-existing beliefs. And so it's not always about 100% about something being compelling, but rather kind of how it hits the beliefs we already hold or kind of what we want to believe. Many more people see the incendiary false version of a story than the fact-checked version that goes out later. So there's a real asymmetry here. The goal of some disinformation and propaganda is not necessarily to convince, but to get people to give up on seeking the facts. There's this idea of the liar. So it's good to raise awareness of deep fakes as well as fake text, fake audio. So we need to warn people not to believe necessarily everything they hear or read or see a video from. At the same time, bad actors can use that then to deny authentic actions caught on tape. And so there's already a kind of example of this with Trump and the Access Hollywood tape that came out in 2016. He initially sort of apologized for it and admitted it was him, and then much later has gone back and said, no, it was faked, it was altered. A kind of related risk that comes up with this, Zeynep Tufekci, who's kind of one of the foremost experts in this area, wrote in Wired, when I talk to dissidents around the world, they often ask me how to authenticate the information they post. Dissidents can end up putting their lives on the line to post a picture documenting wrongdoing, only to be faced with an endless stream of deliberately misleading claims that the picture was taken 10 years ago, that it's from somewhere else, that it's been doctored. And Zeynep definitely recognizes the importance of allowing anonymous and particularly kind of stable pseudonym accounts over time, but here she's kind of arguing for a verification system, and I'll talk more about that in a moment, but kind of this risk that we can lose a concept of truth. There's an idea of censorship via information glut. Anne Applebaum wrote in the Washington Post, do you still believe that some old-fashioned Orwellian form of censorship is the main threat to free speech? The new censors won't remove your words, they'll drown them out. Renee DiResta, another kind of top expert in the area of computational propaganda, referred to this as a kind of social DDoS, distributed denial of service attack, a kind of just overwhelming people with just this quantity of bad or toxic information. And then Zeynep said, it's no longer the age of information scarcity. Censorship works by information glut, distraction, confusion, and stealing political focus and attention, since attention is this very finite, limited resource that we have. Something that will make all of this worse, and in many ways is already making all of this worse, is the way that recommendation systems amplify and incentivize disinformation and incendiary comment. And I'm going to use YouTube as an example, although this is true of all the social networks to some extent. 2 years ago, YouTube hit the milestone of people watching 1 billion hours of YouTube per day. This is a huge quantity of YouTube. Again, YouTube is owned by Google, kind of one of the most powerful companies in the world. And it's much higher now. I believe it's like 4 or 5 billion hours. YouTube said that 70% of this time being watched comes from their recommendation system. So when you're watching a video that you've looked up, there's this side panel that says up next, and the top video will start auto-playing right after your video. This accounts for 70% of the time spent on the platform, these videos being chosen by YouTube. And unfortunately, they disproportionately include some very toxic conspiracy theories, including ones that promote white supremacy, anti-vaxxing, climate change denial, denial of mass shootings, really, really harmful things. Guillaume Chaslot is the YouTube whistleblower. You should definitely be following him and his work. He is partner, so he has a PhD in AI. He previously worked at Google/YouTube, and he has partnered with the Wall Street Journal and the Guardian for investigations in the past. He does a lot of kind of quantitative monitoring of what YouTube is recommending. So one example he gives is that YouTube recommended Alex Jones videos more than 15 billion times. And so to be clear, this is not people looking up these videos. This is YouTube recommending it to people that were not looking for them. If you're not familiar with Alex Jones, he's one of the most prolific conspiracy theorists of the 21st century. And notably, he created the conspiracy theory that the Sandy Hook elementary school shooting was faked, and this has resulted in a years-long harassment campaign against these grieving parents whose children were murdered. He also claimed that the Parkland school shooting was faked. And there was a great investigation recently in Bloomberg where they interviewed 20 current and former YouTube employees, confirming a lot of the ways that YouTube executives have actively discouraged YouTube employees from even looking into the problems or investigating what's going on. Five senior executives have left because of YouTube's inability to address these issues. So Guillaume's done a lot of interesting work. Here he was monitoring what videos YouTube recommends, and we've got this extreme outlier. The x-axis is the number of channels recommending the video for Russia Today's take on the Mueller reports, and here the y-axis is log of views. And so this is something where there seems to be evidence that various actors may have gamed the YouTube algorithm of what gets heavily recommended. Russia Today is the state-owned Russia media channel, and this is something kind of showing that kind of this huge range of channels across the political spectrum were leading to this being recommended. And there's been a lot of other work done on this, so definitely kind of follow Guillaume. So in the last few minutes, I just want to briefly kind of mention some steps towards solutions. So a question I always get is, can we write an algorithm to detect what's fake or not? And I think there's valuable work being done on this. But something to keep in mind is that any algorithm for detecting fakes can also be used to produce better fakes. And this is kind of the idea behind GANs, where you have basically two different models. One's generating and one's discriminating, telling if something's fake or not. And you get this feedback loop of using the discriminator to make your generator more compelling and improve its performance. So this area will kind of always be an arms race. Oren Etziani, the head of the Allen Institute of AI Research, wrote a great article in HBR earlier this year. AI is poised to make high-fidelity forgery inexpensive and automated, leading to potentially disastrous consequences for democracy, security, and society. As an AI researcher, I'm here to sound the alarm and to suggest a partial solution. And he suggests digital signatures to authenticate content. And this is something that will require both kind of the technical tooling to provide these signatures, and then also the cultural change of getting people to not believe something unless it's been authenticated or signed, which would be a kind of huge cultural change. Zeynep Tufekci proposed something very similar in Wired in February, and she wrote it and kind of referred to it as verification and used this analogy with in the past when people would hold up maybe today's newspaper with the date on it for a picture to prove that they were alive on that day. Fidel Castro did this in 2006. He had been sick and there were rumors of, is he still alive? And so he released this photo. And this is something that that would already not work anymore due to Photoshop, but we kind of need a digital analog to that. And then Renee DiResta and Mike Godwin, who is the original legal counsel for EFF, had a great article in Just Security on 7-step program for fighting disinformation, where they frame it as you need to see it as a cybersecurity problem, and kind of looking for manipulative behavior and bad actors. And kind of just one example is, several researchers have now identified the role that Russian trolls played in promoting anti-vaxxing propaganda in the US as well as in Europe. I always want to make a note also that I think a kind of key component of addressing many of the ethical issues we're seeing is improving diversity and inclusion within the tech industry. If you're kind of new to these topics or want more information, the most popular thing I've ever written is a post called "If You Think Women in Tech is Just a Pipeline Problem, You Haven't Been Paying Attention." And that links to dozens of studies and provides a lot of action steps and research if you want to find out more. And then I want to remind you, I know the kind of last part of this talk was a bit dark, that there are positive applications to deep learning, that this underlying technology is being used in a variety of ways, both positive and negative. And as we saw earlier, genomics and bioinformatics research, as well as translation, that there are these positive applications. And I should say that's kind of why I want the field to be more diverse, as well as both for kind of people to recognize different positive applications and to help address the negative risk. Again, this course is available for free online that we put out earlier this week on NLP. I should note the course is kind of primarily on technical topics, but I do cover disinformation and bias as well in it, kind of as important issues. And now I guess, do we have time for questions? Yeah, so thank you.
So I think we have time for probably a couple of questions. So if people have questions, you can raise your hand, they can pass this around. There may also be a mic at the back of the room.
Thanks. Very fascinating talk. I'm curious, in the case you gave of the net neutrality discussion, advocacy organizations for a long time have sent sample text that could be, relayed on to their representatives and so on. How do you differentiate those cases of maybe low effort campaigns from real people versus fraudulent campaigns from...
Yes, that's a great question, and that's not always clear. Yeah, and I should note that Jeff Cow in his post is careful to note that saying only 4% of the comments are unique is not saying that 96% are fake, but yeah, that many of them may be from these kind of mass campaigns where people are given samples of text to send. This can be an issue. Renee DiResta wrote an article for Wired on, there was a case where I believe Ted Cruz's campaign gave people a way to kind of automatically sign something and send this tweet that was kind of preset. And it was something where this was picked up as kind of bot activity because I think they maybe even had a timer on it where it was basically thousands of Twitter accounts posting the same tweet at the same time, where it looked really fraudulent, but people had actually clicked I want to send this. So that's a good point. It's not always clear the line between what is manipulative, inorganic activity and what might be just a coordinated campaign, but people are giving their consent and taking advantage of that.
We have time for maybe one more question. The back there.
So you mentioned verification as a possible answer to the possibility of faking content. That kind of, it feels like it kind of works for if you're reading something where it's verified to be somebody you know, but a lot of this speech is you're listening to strangers. So if it's a stranger and the possibility of getting a signature signed somehow is very widespread, then even the fakes can get themselves signed. So how do do you have any suggestions or thoughts, ideas how to trust a stranger's speech?
That's a tough one. I mean, my impression is that you are going to need to rely on at least trusted institutions of, like if there's a newspaper you really trust and you know that like they're able to verify the speech, you can believe it even if it's, a stranger that you've never heard before. But I do think will kind of be this need for trusted institutions and kind of communities of trust.
All right. Let's thank Rachel once again for